Hi, Dr. Wu.
Hi, how are you?
Good, good. I'm just waiting on others to join in.
Uh-huh.
Hello, Dr. Yam.
Morning, guys.
Hello, good
Morning.
morning.
Is there any documents that we need to fill out with this defense?
So it's after the defense, you guys have to fill out an evaluation form. So I will send it out after the defense.
Do you mind sending it out right now?
Hey, good morning, Prashant.
Hi, Dr. Pandya. Good morning. Yeah, okay.
Yeah, I was actually somehow in a different room.
Oh,
Yeah, sorry. I was there for 10 minutes. There's some other meeting going on. And then I realized this is your ID. Okay.
okay. So we're still waiting for somebody
How are
from
you?
Honors College. Hey, I'm doing good, Dr. Pandya.
Doing good. Wenwu Taho, thanks for joining.
Thank you. Yeah, I was saying if there's an evaluation sheet, is it possible to send it to me
Yes,
before the
I
thesis,
have.
the defense, so I know what to look for?
You doing okay, Wenwu?
Yeah, good. How about you?
How's your baby?
Oh, she's going fast. I mean, she's crawling right now and needs constant attention from the parents.
So she's 6 months now?
She's roughly 11 months now, 10
Oh,
and a
wow.
half. Yeah.
All
How time
right.
flies.
Yeah, the COVID year baby.
Yeah. I mean, yeah. It's really, I mean, it really takes me a lot of time to take care of her because we don't have parents to help and we can't.
Yeah. Is
get her
this is your first child, right?
Yeah, this is my first. So
Yeah, I have only one daughter, but as Taiho can confirm, it gets better after they are potty trained.
okay.
Yeah, right?
Okay.
So there is a period like when around 3 years they get trained, potty trained, and then till like maybe 11 or 12 years age, right?
Uh-huh.
So at around 11 or 12, they realize that my parents are not cool. Okay. So Taiho should be, Taiho understands what I'm talking about, right? So that window is good between 3 to 11,
Yeah. Taho, you are muted. You were saying something.
Yeah.
Yeah.
I talked a lot, but or muted.
Okay. That's okay.
Yeah.
As a married man, we understand,
Yeah. Yeah.
So that
Previously,
age used to be, like earlier it used to be like 3 to 13, 14, but now from that 14, it has come down to 11, 12,
Oh, yeah. It'll soon come down to like 8 or 7.
Yeah. So because, they have so much information now,
Yeah.
they realize, oh, my parents are not as cool as I used to think.
Right.
Yeah.
Right.
Prashant, you don't worry, okay?
Yes, sir. I have some time.
Yeah. Okay.
So we are expecting somebody from the honors school to join,
Yes.
right?
So the Excel sheet said DHG is gonna join the meeting. So
Yeah, they probably this
But
time
as
around.
I know, it's not mandatory from their perspective. I think if they have multiple schedules overlap each other, then they may
Yeah,
just skip
because
just one of them.
I believe this time of the year across the campus, they do like couple of 100 honors thesis defense, in the last
Yeah.
month, April. Yeah. So let's wait for a couple of minutes.
Mhm.
So
okay.
Prashant, what's your plan after graduation?
So I have some offer from grad school, so I got accepted to NC State,
Mhm.
but I'm still
That
waiting. I'm still applying for jobs too, so I have both things going on. But I have a backup as a grad school, NC State right now.
Yeah, NC State in Raleigh.
Yeah, Raleigh.
Yeah, I've been there for 2-3 days. It's a nice campus.
Oh, that's
And
what I
it's
hear.
it's a good school. It's a great location. I don't know if Wenwu or Taiho are famous. So it's a part of that North Carolina region.
Research triangle, yeah.
Yeah, the research triangle. So there are lots and lots of opportunities, jobs, internships. Because there is Durham and Raleigh, and then there's
Yeah.
one more, right?
Chapel.
So did
So
you?
UNC
Yeah.
Chapel. Yeah.
Yeah,
So
and
did
they
you
have.
get? Yep. Go ahead. I just sorry.
Yeah, go ahead, please, Taho. Yeah.
So did you get admission as a PhD?
A master's.
A master's.
Mhm.
So I see a lot of Nepali students around you got admitted to NC State these days.
Yeah, so I know two who got admitted to NC State. I don't know about others, but I know two other friends who got accepted.
Okay. Yeah, I mean Vivek, do you know Vivek Gupta?
Yeah,
I think
he
he got accepted, and Jana also I think got accepted, but he
Oh
declined.
yes, he's not. I think he's not going to NC State.
Yeah, he's not going to NC State.
Yeah.
Okay.
Yeah, Taiho is right. Over the winter, I don't know how many recommendation letters you wrote. I think I wrote around 60 recommendation letters.
60?
Yeah, 60.
Wow.
60? Really?
Yeah, multiple recommendations for maybe 12 or 13 students,
Oh, okay.
Yeah,
okay,
Oh, I see.
and
College
when
students.
Wenwu might be familiar, a lot of international Chinese students are also, those they are working on 2 universities programs. So they also applied to like 8 or 10 schools, and then and also they are applying in different programs, So if somebody applies in computer science and somebody applies in industrial engineering, you want to write the recommendation letter accordingly, So
Then you have to write them differently.
yeah, we should start charging like something, It's just too much work.
Yeah, I think I wrote for about 6 students over the winter.
Yeah.
But I had nobody from Chinese students. I think Chinese students, they didn't ask me.
No, the Chinese students love me because I talk to them in Chinese, They know I lived in Nanjing, so they all want to
You can speak Chinese?
Itian tier, Puhao.
Oh, that's good. That's good.
Wangla.
Oh, that's good.
Wangla.
Wow.
No, actually, I could speak pretty good. In fact, based on my Chinese spoken abilities, I traveled around for 1 month, after finishing my work, and I was still okay. And I went from Nanjing to Chengdu, Sichuan, then Beijing, then Tibet, Lhasa. From Lhasa, I crossed over to Nepal. And all this, I used in fact, I crossed over almost illegally, I did not have the permits. So my Chinese language was very useful,
Yeah.
The authorities there, they love when you talk to them in their own language,
That's impressive.
They help you, Yeah.
So how did you learn? Where did you learn Chinese?
I learned Chinese in India, for a few months, and then actually I was posted in China for, I worked for a company there for a year and a half or so.
Okay.
Yeah, I could have continued to stay for long, but then see, I'm a vegetarian, so it was very tough for me.
Yeah.
Yeah. Okay. Well, your Chinese skill is it's very impressive.
No, I had a great time. I had some very good friends. I enjoyed it. Yeah. I met some good friends. Yeah.
That's impressive.
And Chengdu is my favorite place now.
You like spicy food?
Oh yeah, Lada.
Yeah, right.
Han Lada.
Yeah, very spicy.
Isn't Sichuan the area?
Sichuan.
Yeah.
And then that big Buddha is there, no? Lashan Buddha. Yeah, that's beautiful, man.
That's a big one.
Yeah.
Yeah, I wish I have time to learn some other languages. Like I think Indian gonna be too hard for me. I want to start from Korean or Japanese, and then maybe Spanish.
India has 30 languages, official languages, I believe, 32.
Oh.
11,000 dialects. So don't worry about India.
Yeah, yeah.
I speak more Chinese than most other Indian languages. Let me tell you that.
Yeah, yeah. Very impressive. Yeah.
Prashant, let's go ahead. I think
Okay.
what do you say?
Yeah, I think we can, because the meeting is recorded anyway. So if they want it, I can just send it to them.
Okay. I hope you don't record the first part. Record it from now. Yeah.
Oh yeah, I can just trim it off.
Yeah, just stream it. Yeah.
So everybody can see my screen.
Yes.
Yeah.
Okay.
Yes.
So thank you all for joining for my thesis defense. The title of the thesis is Parametric Design of Flywheel for Electric Punch Press. So I did this on the direction of Dr. Thesis Pandya. So I'm going to start. So these are the topics I am going to talk about today. So I'm going to start the presentation with punch press. So basically talk about what punch press is, how it works, and then I'll jump into talk about flywheel, why we need flywheel in our design, then talk about design calculations, all the formulas I've used, and then I'll talk about the modeling of flywheel, parametric design, and conclusion. So what is a punch press? A punch press is a machine that changes the shape or the shape of the piece of a metal sheet by applying force in a die, which is held in a workpiece. The form and construction of the die determines the shape that's being punched. A punch press has two coacting components, the punch and the die. The punch is attached to the reciprocating ram of the machine, and the die is clamped on the flat surface, and it is perpendicular to the path of the ram. So as you can see in the picture, a punch and a die. So punch press are usually driven by electric motors, and the conversion from rotary motion of the drive shaft to the reciprocating ram is affected by cam mechanism or a crankshaft. Because the power demands are intermittent, a flywheel is attached to the drive shaft of the press so that it can store energy during the idle portion of the cycle and actually deliver the stored energy during the actual punching operation. So thus it helps to use a low power motor. So I have a picture of a punch press here for everybody to see. And I have also a video of a punch press operation, like how it works, an actual punch press. I was gonna play on YouTube. Slow internet.
I think it's paused.
The screen is paused?
Yeah, I think, yeah. I think the video clip is paused, yeah. Probably.
Okay.
Or you can directly go to YouTube and share the link.
Yes, so I think you can see it now.
Okay.
Okay, so this is a punch press working, natural. So now he's gonna insert the sheet metal. And there we go. So that's how it's working. So this is a flywheel. So I believe this is an electric punch press. All right. We have enough idea now. So I'm gonna jump back to my presentation. I'm gonna share. Okay, so these are some samples of sheet metal spar after being punched. So we can see all these holes that were all punched using the punch press. Okay, now we know what punch press is. We're gonna talk about flywheel. So a flywheel is essentially a very heavy wheel that takes a lot of force to spin around. And it is used in a machine as a reservoir that stores energy during the period where the supply of energy is more than the requirement, and releases the same energy during the period when requirement is more than the supply. So the flywheel comes in different shapes and sizes. So the most two common geometries of flywheels are rim type flywheel and disc type flywheel. So depending on the application, different shapes can be used. I'm going to talk about geometry more on the later slides. So why do we need a flywheel? So why do we need flywheel in this punch press? I mean, the punch press could operate without a flywheel, but in that situation, we would need a very large motor. So basically in a machine where operation intermittent like punch press, the flywheel stores energy during the power from the power source during the greater portion of the operation cycle and give up the energy, the same stored energy during the actual punching operation. Thus the energy from the power source of the machine is supplied practically at constant rate throughout the operation. So essentially in a punch press, like max power is required only during a small part of the cycle, that is the actual punching. During the remaining part of the cycle, only a small amount of power is required. So if there is no flywheel, a higher capacity of motor is required because the motor is doing all the work. But if there is a flywheel, then it will store the kinetic energy during the small idle portion of the cycle and deliver the same kinetic energy in the peak load period of punching. Hence, a small motor would be required. So I have a visual here of a graph. So graphs of using a flywheel with and without the flywheel. So as we can see, the pink one is one with the flywheel. The curve is a lot smoother and the peaks are smaller. But in case of without the flywheel, the dotted line, we can see that it has the graph has a lot of ups and downs, and the peaks and the valleys are bigger comparative to the ones without the flywheel. Thus, a flywheel helps to reduce the size of the motor. That's why it is used in a punch press. Okay, so now we know the importance of flywheel in a punch press. So we'll talk about now the designing of the flywheel. Before we design, but we need to know the parameters. So what are the input parameters and what are the output parameters? So what are the formulas? So these are the formulas I used, and it was all obtained from textbook. So the parameters such as holes per minute, holes diameter, thickness of the plate, diameter of flywheel are vital to proceed further. So these all are the input parameters that I've used. And so this is the Excel sheet. I put everything. So these are all the input parameters, and this is the output parameters, which I obtained from all the formulas here. So the input parameters are thickness of the plate, the hole diameter, the material property of the plate, diameter of flywheel, number of holes per minute, and efficiency. So these were all the input parameters that were inputted by me or anybody who's designing a flywheel, and these are the output results. So the output results like energy to punch a hole, the power of motor required, the shearing force, the mass of the flywheel. These are all the output parameters. Okay, so now we know all the parameters. So we know all the design parameters. Now, then after this, we can actually go to the design process. So I used Creo to design the models, and so 3 different looking models were designed. So talking about more on geometry of flywheel. So there's basically 2 main geometries of flywheel: the rim type and disc type. Depending on the application, different shape is used. So the disc type flywheel is a low speed kinetic energy storage system, and it has an RPM range of 6,000 RPM. They're usually heavy and rugged construction, whereas in the other hand, the rim type flywheel is a high speed kinetic energy storage system and has an RPM range of 10,000 plus. They're usually of low weight and small dimensions. When is one preferred over the other? So as the energy requirement and the size of the flywheel increases, the geometry of the flywheel changes from the disc type to the rim type flywheel, because the rim type flywheel has all its mass concentrated on its rim. So and we know the mass of the so we know the moment of inertia is proportional to the radius, and rim type has a large radius. So basically, when the size and the energy requirement is high, we usually prefer the rim type flywheel. Okay, so now we know the design of the flywheel. We can talk about the parametric design. This is the whole thing that's the most important part of the thesis. So after all the calculation modeling, the final step is to link all them together. Creo 7.0 comes with behavior modeling feature. BMX is an ultimate in feature-based parametric modeling through which new features created that ensure changes to geometry and update the rest of the model. So basically so when you change anything on any feature on geometry of any model, the BMX, what it does, it just updates the whole model. I have more on the BMX on the next slide. Okay, so suppose we have a design, so we have to design a shampoo bottle that needs to be a volume 1 liter. The design currently we have is a volume 1.183 liter, that is greater than 1 liter. But our target volume is 1 liter. So in order to get to the target volume, we have to change other dimensions. So to get to the 1 liter, we have to change other dimensions, such as radiuses. So there's 2 radius that we can change to get to the volume of 1 meter. I mean, without traditionally we would go about doing it is do a lot of calculations and do a lot of iterations in the Creo and spend a lot of time and effort to design it and to get a 1 liter volume. But however, then that's too, as an engineer, that is not efficient. So doing the same task again and again is not efficient. But however, with the BMX feature, the solution is just 1 click away. So let's look at the picture. So we have the shampoo bottle that has the volume of 1.183 liter. So regional design with volume of 1.18 liter. The target volume is 1 liter. The variables that can change are 2 radiuses. So we can change the 2 radius values. So now open Creo and go to the BMX feature. So here BMX feature, we see the constant is the volume, the 1 liter that we want. And the variables are 2 radiuses that can change. So we just input the minimum and the maximum values for the radius, and just hit compute. In just a few seconds, we see that we have a new design of the bottle and the new volume is 1 liter as we wanted. So when we hit compute, we can see the design is changed. The new volume is 1 liter and the 2 radius values are different. So we have a new radius values and the new volume. So essentially, we just modeled a new shampoo bottle as required in few seconds. I mean, that is a lot of time saving. And that saves a lot of time and effort and it's a lot of headaches because it took some time to design this shampoo bottle originally. So this is what BMX is. So I have another video of me doing the same thing for the flywheel, for the design of flywheel. So I'm just going to play the video. So this is the original design of the flywheel. This is the Excel sheet with all the parameters. So I'm just gonna give the new dimension here. Click on the BMX feature, regenerate the model. Okay, so we have the new, this doesn't look like a flywheel, but we have a new model regenerates, but I'm gonna change the dimension again. Okay, so now there we have another model. So basically I changed the model twice in just few seconds using this BMX model. So the video is basically the point of the whole thesis. It shows how I've automated the design process of modeling a flywheel. I mean, the design automation is very useful. I think, in my opinion, in a company that is offering custom parts and products. I mean, without automation, but traditionally everything has to be done manually, and that puts a lot of effort. That puts a lot of pressure on design engineers because they have to do the same task again and again, rather than focusing on something innovative and add value to the new design. They are just working on the same design but with different dimensions, and that puts a lot of effort on the engineer. So if the automation is applied to such time-sensitive and often repetitive tasks, So the company will definitely reap benefits, and that will definitely take the pressure off all the engineers. And interestingly, one survey indicated that a typical company recreates the same geometry for like more than 5 times as the customer proposals or market specifications. I mean, that is a lot of time and resources wasted on such a simple task when we think about it. So I think so the answer to the problem is automation, the automation of design process. And I believe the automation has it's a huge opportunity to speed up the design and make design process more dynamic. So basically, in conclusion, the work focused on demonstrating automation of engineering process as a part of design of engineering components using flywheel of a punch as a representative example. That's all I have to present. Have any questions? I mean, I think we have a lot of questions.
Yeah, so objective of the study is to explore this design automation function embedded in Creo rather than optimizing the design of the flywheel. Which one was the objective of the study?
It was it was automation more than the optimization.
Okay, so I see. So more focused on exploring the functions of design automation in Creo. Okay.
Yeah, before this project, like I had no idea about this feature, BMX feature. Like it was hiding in plain sight. I mean, I think it's very useful. I mean, there is a lot of optimization, but I didn't use a lot of optimization. I just explored the BMX feature and just did the automation.
Okay, so the way that this Creo, this design automation function works is that you change the input parameters, then accordingly, just Creo updates the design.
Mm-hmm.
Rather than you set certain engineering goal in terms of, let's say, I want to increase the efficiency of this flywheel, then the certain optimization algorithm is used within the Creo, and Creo just try to find the most optimized design for obtaining that goal. Which one? I mean, do you understand what I'm asking?
Yes, so I saw the optimization and feasibility study in the Creo option. Yeah.
So let me try and answer Taiho's question. So Prashant can also appreciate that. So basically, the initial goal for this work was to through this automation process, build a working model of a punch press, and see how we can reduce the time to build a system if the design process is fully automated. So let's say an example is that if a company is designing punch presses, and the company gets an order to design a larger capacity punch press from, let's say, from 500-ton punch press for shaping the body of an automobile, the sheet metal body. They say, okay, we get an order to develop a 1,000-ton punch press. A much thicker sheet metal needs to be formed. So now the engineers will have to go on a drawing board and then do the calculations again, and figure out how much force is required, torque, and size the equipment, all the components going into the machine. So if the design process is automated, then based on the input parameters, like the material of the sheet, the thickness of the sheet, etc., we can size the new punch press, and then with connecting through this behavioral modeling extension of this CAD software package that we are using, it can provide an updated CAD design, CAD model. So it will also give you the manufacturing drawing. So you can go to this, get these manufacturing drawings quickly, based on all the parameters that you have inputted, and then you can get those parts made. So the idea is a lot of time engineering work contracts are won based on how quickly you can meet a customer's requirement. When customer thinks of something, he might take 1 year to decide that he wants these new presses, but then when he when he puts the order with the client, he wants it immediately.
Yeah.
So the idea is to reduce time to market. Okay, so the moment you get the inputs from the customer that we want this kind of a design, same with like what Prashant talked about shampoo bottles. You want to change the geometry of a product, right? So Coca-Cola bottle would come in 1 liter, 2 liters, 1.5 liters. So the volume is determined by the marketing team, right? That we need to keep 1 liter. But then the shapes are also decided by the aesthetics or the packaging team, that how the bottle need to look. So how would you keep 1 liter volume constant while tweaking the shape of that juice bottle or a shampoo bottle or a soda bottle, right? So these kind of features, so he tried to demonstrate that using the flywheel. So the initial idea was to use this information and then see how quickly you can make this part, and he was to build a small working model. But because of a lot of COVID restrictions, limited access to the
Yeah.
manufacturing facility last semester, he his work is mainly theoretical right now.
Okay. Yeah. Understand. Yeah.
Yeah, that was basically it.
Yeah.
You explained it very well.
Yeah. So basically, this optimization process is just driven by the input parameters, which are given by the user, right? It's not like Creo automatically explore the ranges of parameters and to obtain certain target defined by the.
No,
Okay.
everything is given by user. So like I
Okay.
was so like the shampoo bottle, it was like I need 1 liter volume, but
Okay.
so like I input everything to the Creo
Sure.
and it just gives
Sure.
out this design.
Okay.
So Taiho, there can be some what you call, when you do the optimization study, you can set
Mhm.
some priorities. For example, you can set some constraints. So let's
Yeah.
say if you are designing a 2 liter Coke bottle and you want to get some new aesthetic shape,
Yeah.
you can put a limit that the minimum diameter of this bottle can be, let us say, 6 centimeters, and the maximum can be 10 centimeters.
Yeah.
And then it will play within that range.
Yeah.
So from the point of view of aesthetics or from the manufacturing requirement, how that bottle is going to be mass produced,
Yeah.
using some molding method.
Yeah.
So those kind of parameters. So same way here, for a flywheel, flywheel is just an example here. So we can put a parameter that the minimum diameter needs to be this, and the maximum width of the wheel needs to be this.
Yeah.
So that way, what happens is that because that component eventually fits into a bigger machine, if it is too large a diameter, then it's going to stick out of the machine, right?
Yeah. Yeah.
So you can say that the maximum diameter we need here is 24 inches, let's say,
Mhm.
and the
Yeah.
maximum width is this.
Yeah.
And then Creo can do the magic. So, it can do the optimization study and provide you with a number of alternatives.
Yeah. Yeah.
So it's a pretty interesting way to go about, designing, because the idea is to reduce the time
Yeah.
while,
Overall designing
yeah,
process time, right? Yeah.
yeah. Any
Yeah.
questions?
Thank you.
Yeah, Mr. Douglas?
Do we have Miss?
Oh yeah. Well, I apologize for arriving late.
That's okay. Yeah.
I'm fascinated by the flywheel concept of just, and I'm not really sure what to ask. I guess the only question I would ask when I'm outside my range of experience is if I wanted to, if I were a competitor, how would I, or someone who wanted to sort of really challenge your work, Prashant, where would I take my questions? Where do you understand to be the weakness of your presentation and your model? How would I come after you? So I need you to confess your weakness, perceived weakness.
So the weakness.
Where do you feel vulnerable in your presentation in terms of the strength of either the idea or the actual implementation?
So the BMX feature is where would I feel attacked if I was to be attacked. This is where would I be attacked, because it's such a vast feature. I just explored like lit on the surface and I could get all these, but if I had gone all the depth, I mean, there's so many things inside this. So this feature, BMX feature, is where is the most, vulnerable thing on my presentation here.
Actually, this is something that I have used in the industry. That's why one of the things I recommended. So in the initial plan was to build a working model, but because of the restrictions, and Prashant was very excited about getting his hands dirty in the machine shop. But because hopefully we will be soon past this pandemic, and students can get more hands-on with these projects.
Thank you.
Thank you. But yeah, honors school is a great platform for students to venture out and kind of explore new ideas and go beyond the classroom. It's definitely a go between a undergrad program and a master's program, somewhere in between.
Excellent. Well, I'll confess that my father he's a mechanical engineer out of Texas A&M. And he wanted
Oh, okay.
But I abandoned the family tradition, so I'm living through that shame. So
yeah, so
I enjoy hearing you three, four Mechie go at it. I enjoy it.
Yeah, so my family, coming from India, they give me all the freedom to choose whatever I want to study, as long as it's engineering or medicine.
I know that. I've heard that.
Okay, if nobody has any questions, we'll stop here. I'm sure Mr. Sullivan has a lot on his plate right now, next couple of weeks, with so many honors defense. So Prashant, if the committee is required to sign any forms, please send it to us.
So I've already sent the what is it, the evaluation link on the chat.
Thank you very much. I'm going to exit. Let y'all enjoy.
Okay. Thank you for joining.
Thank you all.
So no problem, Prashant. I'll just look into the email and find it. Okay.
Awesome. Thank you.
Yeah,
thank you.
Yeah. I mean, the number of emails nowadays have gone up very high because Taiho, we have in ME 324, the junior design, there are 23 projects.
Yeah.
In my code, and then capstone design, that exhibit is next Tuesday. I had 20 projects in that.
Yeah. So you're managing like 40 projects.
43 projects. Till last year, capstone was offered by 2 faculties. And all this. See, the problem is this: in classroom teaching mode, you are teaching stuff, and it's common for everybody. But now every project here is group specific, right?
Yeah.
So, and it's all different, so one group can come up with something and ask, and so I'm losing my sleep over this. I hope this gets over soon. Yeah, I'm telling you, it's because and every group acts like I know everything, and I don't. They need to fill me in, give me 2 minutes to kind of find my bearings, where am I in that project, But no problems, Prashant. Good presentation, and I wish you good luck for your rest of the semester. And thank you, Wen and Taiho, for finding time to join this.
Thank you.
Thank you. Thank you all.
Okay. Take care, Prashant. Yeah. Bye.
Yeah.
All right, Prashant, I think we'll send you those forms, or I suggest you just send it one more time to the committee, so we'll quickly sign it. Okay.
Okay, so thank you, Dr. Vanya.
All right, take care. Okay, it's a good presentation. Yeah, you communicated well.
Awesome. Thank you.
Yeah, that's what we need. In short amount of time, how to convey the idea. Okay.